Alright, so today we're doing acid-basis nomenclature. First, we have sulfuric acid. We know with the ick, it's going to have a polyatomic ion, and we know sulfur is going to be our base. Now, I don't have my polyatomic ion sheet, but I know that sulfur's polyatomic ion is going to be SO4 -2. But acid always gives us an H +1. So to combine these, we're gonna have to pull it down. We're gonna have to do H, and we flip the charges. So it's gonna be H2, and then SO4. And we don't recognize that one. We don't need that +1 because we don't use them, or we use them. We just don't put them in. We don't recognize them. Now, for CaOH2, we know that Ca is calcium. And we know that the H is always acid, and it's O is oxygen, so it's gonna be hydroxide, but we need to we changed the oxygen to oxide, and it has the hydro because of the H. So that's what we get from that. Now if we can do another example, give me 1 second. We can do something like potassium hydroxide. Potassium hydroxide. And for that one, so we know what potassium is. Potassium is K, and we can look at our periodic table right here and look at K is going to be in your first column. And so K has a +1 charge. And now we're going to find the hydroxide is going to be just like what we did up here. It's just going to be OH -1, but we ignore these two ones, so it would come out to just be KOH. And so another example for this we are going to use is going to be HNO3. Now, NO3 is, we know that is nitrogen, so that's going to be nitric because the gin turns into an ick, and we know that the O3 is oxygen, but with the H we have acid, so it's going to be nitric acid, because that NO3 in the polyatomic ion sheet is nitric. So nitric acid, because we have acid here, and I did not spell acid right. But yes, that's how we find the acid-based nomenclatures. That's how you go from the words to the nomenclature, and nomenclature to words. Thank you.